Hello guys and welcome to another video of the MYP Masterclass. Today we're gonna be seeing some physics and we're gonna be seeing more specifically what is the universe made of. So going straight to the point, the universe has three main building blocks, and those are dark matter, which makes up 27% of the whole universe, and it does take space and holds mass, but it doesn't reflect, absorb, or radiate light. What does this mean? This means that it is not visible neither for us nor technology. So basically, it's all the dark thing you call space, and you see around the planets, the stars, all that's called dark matter. The second one is dark energy, and this one is even more complicated, and it actually makes most of the universe, which is 68%. But scientists don't really know much about it, and it's kind of more like a theoretical energy. But it is known that it has to exist because it's the only way to explain the universe's accelerating expansion, which is something we'll see called the Big Bang Theory, as you may know it about. But we'll see more of that on another video. And then we have the visible matter, which actually takes 5% of the universe, and it's basically the normal matter that makes up everything we can directly observe either through our eyes or technology. And well, you guys see that the universe is actually very big and we only know around 5%, but today we'll only concentrate on the visible matter. So imagine you have a mug and then you cut it in half, and then you cut it again and again and again, and you just keep cutting it until you basically cannot see it. So do you think you can keep going until, I don't know, molecules, atoms, and whatever? Well, what's actually the smallest thing in the universe? And everything in the universe is made of fundamental particles. And what does fundamental mean? Fundamental means that it cannot be broken further down into smaller pieces. So that's actually the smallest thing in the universe. And the fundamental particles actually divide into 4 groups, which are the quarks, the leptons, the gauge bosons, and the scalar bosons. So all these particles interact with each other according to a theory called the Standard Model, which we'll see later on. And well, all matter is made up from these particles, elementary particles, quarks, and leptons mostly. And the smallest unit in any of the elements in the periodic table is the atom. So here we have the atom structure, and well, we basically have the center, which is called the nucleus, and it's made out of protons and neutrons. So if we go back here, the protons and neutrons are made of up and down quarks. So the protons and neutrons can actually be broken down into quarks. And then we have the electrons, which are these green things, and they rotate around the nucleus, just like the solar system and the planets rotate around the sun. And the electrons are actually negatively charged particles. Now, if we go back again here, the electrons are part of the leptons group, so it is the smallest particle you can have. You cannot break it down any farther. And now if we combine a lot of these atoms together, we make a molecule. And a molecule is basically all those elements you can find in the periodic table. So like carbon dioxide, which this in this case, well, this is a carbon atom, or hydrogen, helium, a boron. So yes, and well, this all these three particles, they're called subatomic particles. So how many quarks are in a subatomic particle, and how can we break it down? So basically, this one on the left, it's, well, a proton, and it has more up quarks. It is made of 2 up quarks and 1 down quark, and this has a positive charge. And here on the right, we have the neutrons, and it has 2 down quarks and 1 up quark. And this is the heaviest of all the subatomic particles, but it has no charge at all. That's why I call it neutron, because neutral. And well, in this case, as we already said earlier, electrons are part of the leptons, fundamental particles, so they cannot be broken down any further. Now, well, seeing some of the recaps, some of the more important stuff we need to know, what is the meaning of fundamental? And well, fundamental means that they cannot be broken farther down. Now, this is a question that will appear in one of the exams, and either if it's the final or a unit exam, it will appear. So it's important to remember fundamental particle, that it cannot be broken down further. Now, what's the size of an atom? And here's when our last lesson comes in. So atoms have a radius of about 0.000000001. I'm pretty sure I didn't say all of them, but how can we actually represent this without having to write so many zeros? Well, that's when scientific notation comes in. So as we saw earlier, if we convert this into scientific notation, it will be 1 times 10 to the negative 10 meters. So now it will be a little bit more readable. And why have we only investigated visual matter? This is more like a conceptual thing, but we're still gonna present it, and it's basically because it's the only one we can see through our eyes and through technology. So as you guys remember from the beginning, dark matter and dark energy are, well, dark matter, we know it exists. Dark energy is actually theoretical, but we cannot see neither of them, even though that they make most of the space. So they're impossible to investigate for now. Maybe in the future, I don't know, we'll get someone to actually be able to see it, but for now, that's all we can have. And this can give you guys a really good understanding on how big the universe actually is, and the really small part that we have actually investigated, which leaves a lot of unknown stuff still to investigate. And we'll see how the knowledge of the human beings keep growing over time. So this was the video. It was quite short compared to the other ones, but I hope you guys enjoyed it, and I hope you guys understood a bit more about atoms and, well, yeah, the basic building blocks of the universe. See you in another video, and yeah, remember, we'll upload every Thursday, and I'll read you guys in the comments.